Hello, everyone.
Hola.
And we're going to talk about what they call mean absolute deviation. Okay? Three kind of big words there. But it would seem like if we break those words down, you guys actually know a lot about each of those words. What is the word in math, what we're doing now, what does mean to do?
Average.
Yeah, we're going to find the average of something. Okay? Can somebody explain what absolute value is? What do you guys know about absolute value? There was always a bunch of absolute values in the weekly reviews at some time. Great?
Value.
The what?
Like complete.
Complete value, something like that. Okay? It was actually the distance, those symbols. Put your hands up in the air. Our absolute value were those symbols, up and down lines on the sides of numbers. And the absolute value of a number is just its distance away from zero. And then deviation. Okay, have you heard the word deviation before? Jot that maybe up top. Deviation. Okay. Do you guys want to deviate from the norm? Yes or no?
No.
No.
Why not?
Because
And it's a new word and it's weird and bad.
No. You guys know what it means to deviate from the norm?
leave
Okay.
reality.
Deviation means how far from, I write form, how far from the average. That's what deviation means. Okay? If the average test score is 90%, the average test score is 90%, do you guys want to have a high deviation?
Yes.
Yes.
The answer is maybe.
Unless
Okay.
it's higher than the average.
Right. If it's higher than the average, you would want to deviate, yes. But do you want a lower deviation from the average? No. It's a
In
bad
some
thing.
points you can,
What? What don't you understand?
like lower.
Okay.
Perfect.
If you deviate from the average, deviation means how far from the whatever the data we're talking about. Let's talk about test scores. Do you want to deviate from the average test score? What if it's above it? Right? Yeah, exactly. If you want to deviate above the average, yes. But if you want to deviate below the average, no. Okay? So that's a bad and a good example of the same one. Okay? Go ahead, Harrison.
What if it's not an average for like a test score? What if
Exactly.
it's about like deaths or something?
About what?
Deaths.
How about height? Okay? I think, do you guys know who Manute Bol is? He's a basketball player that was like 7'6". He deviates from the average quite a bit with his height.
There was a guy that was 7'10" when we at the Navy place in DC.
Oh yeah?
Said this one of this guys that came to was like 7. He left. He came like 7'6" and left 7'10".
Really? So he grew 4 inches.
Yeah.
There you go. So he would you agree that he deviates from the average height? So there's one that's we're not good or bad, you know? So
It is kind of.
we're gonna talk about the average, absolute value, how far from the average, deviation. Okay, and I'm gonna show you guys step by step on how to find it. All right, the mean absolute deviation we defined as color. Mean absolute deviation is the average. There's that word. It's the average distance. There's absolute value thrown in there. It's the average distance between each data value, bless you, each data value, and the mean. Do you guys think taking average is easy or hard?
Easy.
If you have your calculator, especially.
Easy.
Easy if you have your calculator. You're going to find the mean for every problem twice. But it's not the same mean. They're two different means. Watch what happens here.
Moving box.
He's jealous.
All right, here we go. The table shows the heights of the first 8 people standing in line to ride a roller coaster. We're going to find the mean absolute deviation for this set of data, and then we're going to describe what it actually means. I had to look up what it, what does it mean? That's what you guys always want to know is, why do we have to do this? What does it mean? All right, here's how we do this. Step 1. Nice thing about this stuff is that you don't have to order your numbers. You don't have to put these numbers in order. Okay? Because all you have to do is find the average. To find the average for some data, do they have to be in order?
Nope.
No. Okay? So we got 8 people here. To find the average, add them all up. Carefully type them into your calculator.
1,000.
And always write down, guys, what the total sum of all your numbers is. And then we got 1, 2, 3, 4, 5. We're gonna divide by 8. So when you get a total of all those,
393.75.
oh my God, Master's saying weird things. It works out evenly. What's the total of all of that? No, the numbers. 390 what? Just 390?
Inches.
Somebody verify that. No. Okay, you guys gotta be way more careful in this
I
video.
got 448.
448?
That's 300.
All right, verified. 448.
And then
Guys, do not
56.
miss problems because you can't type something into your calculator. Okay, that's a bad reason to miss the problem. Divided by 8, you should have got 56. Look at the numbers. Does that look like about the average?
Yeah, right in the middle.
56. Not in the middle, that's the median. The 56 means the logical.
It's about the
Yeah,
middle number,
56.
so-
All right, so your first step is to find the average. Now, here's where there's a lot of work that you guys got to do. You're going to find the absolute value of the differences between each set of data, each piece of data in that table, and the mean. So you got to do 8 problems now. Here we go. Absolute value. Let's see. What's the first piece of data? I got to scroll up a little bit. What's the first piece of data, guys? What's the first guy's height?
52.
The absolute value of 52 minus the average, 56. The absolute value of 52 minus the average, 56. Believe it or not, everybody in here can do that in their head.
4.
-4.
It can't be negative. Remember, absolute value
4.
means distance away from 0.
Oh, I was.
No,
Four.
So you do 52 minus 56, which is -4. Hopefully you guys can do that in your head. Count from 52 to 50. It's 4. And then, but the absolute value of it is always positive. It's going to be positive 4.
And you don't switch the sign.
You don't switch the sign.
When it's
If it's-
negative, turn it positive.
Yeah, but if it's positive, it doesn't turn into negative. Only negatives turn into positive. Miss Teddy,
How did you get 52?
great question. Find the absolute value of the differences between each value in the data set.
So you have to do all of them?
I gotta do all of them and the mean. So, I just did the first one. It's 4. Watch this. Teddy, what's the second piece of data in the table? Nice. 48 minus 56, the average. Is anybody smart enough to do that in their head?
8.
8. Okay, remember the absolute value is going to be positive. Now, I'm going to do 60 minus 56. It's not -4. It's always positive. It's a distance from 0. You do these stuff inside your absolute values first, and then you say how far is 4 away from 0? It's 4 from 0. Okay, you'll do this a lot quicker than what we're doing it up here. 55 minus 56, 1. 59 minus 56, 3. 54 minus 56, 2. Okay, got 6 of them done. We got 2 left. 58, the absolute value of 58 minus 56, which is 2, and 62 minus 56, which I think is 6. Okay, you have to find the absolute value of the difference between each value and the mean. You guys see why we're letting you guys use these notes maybe on a test or quiz? There's no way you're going to remember that stuff. Okay? But we got a step-by-step process here. Now, those are the numbers we're going to do something with next. Step 3, find the average of the absolute values of the differences between each value in the data and the mean. You're going to find the average of those 8 numbers now. So that's why I said you were going to find the average twice. You're going to find the average of everything, and then you're going to find the average of the difference between the absolute value and the mean. So, again, we're going to divide by 8. Everybody add up those little small numbers. You can probably do it in your head if you really thought.
30.
30. And what's 30 divided by 8?
3.75.
3.75. Guys, that's the mean absolute deviation. 3.75.
How'd you get 30 again? You added up the four.
You ended up with the little
Oh,
numbers.
okay.
We found the average of the 8 numbers we just found in the previous step. Does that make sense? So, the mean absolute deviation is 3.75. The smaller this number, the better your data is. I'll say it again. The smaller that number, the better your data is as far as how accurate is your data. Okay? Keeps moving on me. Okay, here's the deal. Guys, are all those people about roughly the same height? Yeah. That means it's going to be a pretty good standard mean absolute deviation. This means that the average distance that each person's height is from the average height is 3.75. Okay? Each person's height from the average is about 3.75. Or it is exactly 3.75. You're going to need your notes to do your homework tonight. We will not give you a ton of data pieces when we do this. I mean, I think Teddy was thinking about that. What if you had a set of data with 100 pieces of data in it? Could you do this problem?
Yeah.
You could, but it would take forever. You'd have to subtract 100 times each piece from the mean.
Wait,
So,
I have a question.
go ahead, I'm
So
listening.
if the average person is 3.5 whatever away from the average height,
Yes.
then they aren't average.
What?
They're not average if they're like away from the average.
Sure they are. They're,
What are you saying?
I understand what she's saying. They're not right on the average.
Like the average person
Is-
is this much away from the average.
But think about it. What's the average height of everybody?
56.
Yes. Each person is, on average, 3.75 inches away from the average.
Okay.
That's what the mean. That's what the mean absolute deviation means. Maeve, okay? All right. Rocco scored 8, 14, 10, 7, and 13 points in his 5 basketball games. Let's find the mean absolute deviation for this set of data. Five numbers is not going to be bad. Okay? One. Everybody find the mean of Rocco's
52.
scoring. I think that's the total.
Oh, yeah.
52 divided by
5.
5.
10.4.
Guys, Rocco averaged 10.4 points per game. Okay? Step 2. This is kind of the long step. You're going to take each piece of data. First one is 8. You're going to subtract the mean from it,
2.4.
and you're going to find the absolute value of it. Since there's decimals in here, I don't care if you guys can use a calculator. But everybody type in 8 minus 10.4. I'm going to take the absolute value of that number. 14 minus 10.4, absolute value. 10 minus 10.4. 7 minus 10.4, absolute value. And 13 minus 10.4. You got to write that out, guys, unfortunately. That's the showing your work. Jack Mears, did you get all 5 numbers? Talk to me.
I did.
So you would add them all
Oh, no. Give me the numbers first.
up. 2.4.
I got 2.4.
3.6.
3.6.
3.4.
I did not get 3. Well, do the 10 minus 10.4 first.
Oh, I skipped the 10. It's 0.4.
0.4. Keep going, Jack.
Or 3.4.
3.4.
2.6.
And 2.6. Okay? So, that's how far he was away from the average on all of his games. We need to find the average of those numbers now. Again, we're going to divide by 5. So, Add up your 5 numbers, people, that you got when you subtracted your mean from each piece of data. What was the sum of all that?
12.4.
12.4. That's the sum. Divide average. Divide by 5.
2.40.
That's what I got. Was 2.48. Anybody smart enough to figure out what that means yet? What does 2.48 represent in this problem? What does it mean?
However much.
How would you say it, Colin?
All of his games were in like the radius of 1.8 on the average.
I don't think all of them were. Change that to a different word and you could write. On average, he was 2.48 points away from his average. That's what it means. Okay? Here's how we're going to write it. Write this down, guys. This means the average distance each data value is from the mean is 2.48. Okay? Write one sentence like that, guys, when you guys do your homework. This means that the average distance that each of his data values, that each of his points scored from the mean is 2.48. Okay? Again, you only got a couple of those to do tonight. Harrison.
Can I put any eraser for my pencil?
No, you're fine. All right. Next, we're going to talk about standard deviation. Okay? Have you guys heard of standard deviation before?
Maybe.
You guys know when you get your math scores back? Do you guys ever look at your math scores when your parents look at them, or do you guys not even care at all?
I don't.
There's a standard deviation around your score.
Oh, yeah.
Which well, like let's say you guys are roughly in the 230s. Let's say you got a 235 on your math score.
That was me.
Okay, 235. Around it, it'll say, and I think these are accurate. It'll say 232, and then Harrison 235 will be bold in the middle, and then it says 238. It means the standard deviation is 3, and it means if you took it again, you would probably get somewhere between 232 and 238. Okay? Standard deviation. Here's what we're going to define it as.
Wait, so,
Go ahead.
so the standard deviation is the first
It's something like that, but it's not those exact numbers. It's not the median of the lower half or the upper half. Good thinking, though. All right. What it is a calculation. No, is a calculated. So they're going to be nice to you guys, and they're going to give you the standard deviation. Do you guys know that you're probably going to have to take a stats class when you go to college? When you get in college, no matter what your major is, you got to take a stats class. You'll find the standard deviation then. Okay. Today they're going to be nice to you guys and give you the standard deviation. All right. Standard deviation is a calculated value that shows. Sorry, we're sneaking all these notes in, guys. That shows how the data deviates, there's that word again, from the mean. Okay? It's a calculated value that shows how the data deviates or differs from the mean. All right, here we go. Couple, I thought, important information about standard deviation. In a given set of data, most of the values fall within one standard deviation of the mean. Here's how we're going to do it. Add the standard deviation to the mean, and then subtract the standard deviation from the mean, and then most of the data would be in that range. For example, let's say the average is 21, and the standard deviation is 3.5. Then most of the values fall between add 3.5 to 21, 24.5, and subtract 3.5 from 21, the mean, you get 17.5. all the numbers that are in between 24.5 and 17.5 are within one standard deviation of the mean. Okay? Let's do one now. The standard deviation of quiz scores for the class is about 1.2. Everybody circle the 1.2. They have given you the standard deviation. Describe the quiz scores that are within one standard deviation of the mean. Step 1, find that mean of the data. Okay? Must have been a 10-point quiz or something like that. Find the average quiz score.
$99.
12, we're going to divide by 12. Somebody verify that the sum is 99.
It's 99.
99. Everybody divide 99 by 12.
8.25.
8 point what?
25.
Chill.
Yo, Miss
You can
Boston
answer
Pants,
every
relax.
question.
Get some sleep, man. Not now, but get some sleep. All right, the average score is 8.25. Is that a logical average?
Yeah.
For this test, for the quizzes?
Mm-hmm.
Yeah. You know, you got a couple 10s, a couple 9s, a bunch of 8s, and then a 6 and a couple 7s. 8.25. All right, here's what you're going to do. Everybody add the standard deviation to the average. 8.25 plus 1.2. How much is that?
9.45.
9.45. Now subtract the standard deviation from the average. Do 8.25 minus 1.2.
7.05.
7.05.
Yeah, that's right.
Guys, here's what this means. All the people that scored in between 7.05 and 9.45 are within one standard deviation of the average. Okay? So, got this down. Quiz scores between 7.05 and 9.45 are within one standard deviation of the mean. Mean means average. You're not write the word average, it's fine. So all the quiz scores that are in between 7.05 and 9.45 are within one standard deviation of the mean. That means they're in good shape. People that are outside, or quiz scores that are outside of that, are more than one standard deviation away from the average. Okay? Let's try one more. You guys are doing great. The standard deviation of posts on a website is about 26.7. Every circle 26.7. That's a
They spelled
huge
site
standard.
wrong.
That's a huge standard deviation. Okay? Describe the posts that are within one standard deviation of the mean. All right. What's our step 1, guys, to do?
Find the mean.
Oh, divided by 10. So carefully, everybody add up those numbers, the number of posts on a certain website. Take your time. Add them all up.
They spelled site wrong.
Huh?
They spelled site wrong.
What did I spell wrong?
S-T-I-E.
Oh, site. Thank you.
1,757.
What'd you get, Matthew?
1,757.
Right here. 1,757?
Yes.
That's what I got. So, if you add up all those numbers, guys, you get 1,757. Can you guys divide by 10 without a calculator?
Yes.
Yeah, you move that decimal one time to the left. 175.7 posts is the average of the number of posts on those websites. Now, here's what you're going to do next. Take the average, subtract the standard deviation, which we know to be 26.7, and then add standard 26.7 to that number. And what are those two numbers when you do that? Please. The big one's 202.4. What's the small one?
201.7.
I got 149.
149.
149 when you subtract it, and 202.4 when you add it.
I did the wrong one.
Take your time. Okay? Here's what this means. The number of posts between 149 and 202.4 are within one standard deviation of the mean. How many posts are within one standard deviation?
139.
No, how many of those
One.
pieces of data are within one standard deviation? Let's see. The first one, yes or no?
No.
Yes.
Yes. Second one,
No.
no, it's not in between 149 and 202. Next one,
Yes.
next one,
No.
next one,
No.
next one.
No.
OMG. Next
Yes.
one, next one,
Yes.
next one,
Yes.
last one.
No.
Guys, this is a bad set of data, I'll tell you that right now. You know why? Only half the numbers are within one standard deviation. The other half are outside the one standard deviation. That means it's not a great set of data. Okay?